Hello students, welcome once again to Chem is Try. We've already talked about how to draw graphs, especially in integrated science practical. In that case, you realize that the values for the horizontal axis and the values for the vertical axis are all spread out. So we begin drawing the graph from the origin in such cases. Then we have our scale, and we keep our constant intervals according to our scale. In this video, we are going to talk about a graph, a special kind of graph. It's just a normal linear graph, but what makes it special? Let's look at our values over here. We have values for L in centimeters and values for t squared in second squared. Then we have been asked to plot a graph with L on the horizontal axis, then capital T squared on the vertical axis. If you look at the values for the capital L, they have been spread out quite fine. But look at the values for the vertical axis. They are not that spread out. In fact, they are so close to each other. And what did we say about drawing graphs? Whenever you draw a graph, make sure whatever graph you are drawing on the graph working area occupies more than half of this area. By looking at how close these values are, you can't draw a graph that will occupy more than half of the graph working area if you should start from 0. So we do something, and that is what we are going to talk about today. We break axes. We are going to learn how we break axes, and after breaking axes, how we are going to take our readings to draw our graph. Let's delve into it. Now, for the horizontal axis, the value starts from 10 and ends at 40. Remember what we said about choosing a scale. We use the values 1, 2, 2.5, and 5. We could also use multiples of these values depending on our values that we have on our graph. So if the values are quite huge, we can use 10, 20, 25, 50. If our values are in the hundreds, we can also use 100, 200, 250, or 500. We just have to make sure all our values enter the graph and the graph becomes as large as possible. So you choose whichever scale will be appropriate for you. But always remember, you are choosing the scale based on the multiples of 1, 2, 2.5, and 5. Please, don't choose scales with multiples of 3, multiples of 7, multiples of 8 and 9. They are going to give you troubles. Please. So always, to be at the safer side, choose a scale using values that are multiples of 1, 2, 2.5, and 5. Or, depending on your values, you can choose scales that are sub-multiples of 1, 2, 2.5, and 5. What do I mean by sub-multiples? Sub-multiple of 1 will be 0.1, 2, 0.2, 0.25, 0.5, or 0.01, 0.02, 0.025, then 0.05. You can go on and on and on. But please, make sure you use values that are multiples or sub-multiples of 1, 2, 2.5, and 5. Good. So let's look at our values for the horizontal axis. Now, on the horizontal axis, we always have 10 bigger boxes. Now, this is my graph sheet. This base is not appearing well, 1. And 2, there's nowhere for me to write my values. So I'm ignoring this first box. This first big box. I'm not telling you that whenever you are doing a graph, ignore the first bigger box. No. This one is a special case. With my graph board, I have no place for writing the values. That is why I'm ignoring the first bigger box. So I have 10 bigger boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my values range from 10 to 40. If I should use 1, 2, or 2.5 as my scale, 2 for example, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's a good scale, but the values from 25 upwards wouldn't enter our graph, so we cannot use it. So you have to go up a bit. So consider a value like 5. 5. So if you go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now the graph has spread out quite fine. And every value over here is entering. So for this set of values, on the horizontal axis, I'm going to choose a scale of each bigger box being equal to 5 centimeters. So 5, 10, 15, 20, 25, 30, 35, 40, 45, then 50. So I can get my values from 10 to 40 all on the horizontal axis. No problem at all. Let's look at the values of the capital T squared, what I'm going to plot on my vertical axis. You can try choosing any scale. It ranges from 2.641 to 3.598. So if I should choose each bigger box being equal to 1, I will have 1, 2, 3, 4. This is where the graph is going to occupy. And the graph is going to be so small. Now, when you draw a smaller graph, one problem you encounter is you might be asked to calculate or look for the value of t squared given a certain value on the horizontal axis. That will give you problems. That will give you problems. But first and foremost, please, let's try and label our axis. This axis is called our capital L, and the unit is in centimeters. And the vertical axis is called capital T squared, and the unit is second squared. So let's try choosing an appropriate scale for the vertical axis. So on the vertical axis, we want the graph to be as large as possible. So what we do is, we tell them, this is 0. We know we are supposed to start from 0 all the time. But looking at our graph, if we start with 0 and move accordingly, our graph will become so small. So we want to start with a bigger number and keep a constant interval. Let me take that one again. We want to start with a bigger number, not 0, and keep a constant interval. Now, when we do that, we say we are breaking the axis. Here, 0, 5, 10, 15, 20, and so forth. And we can see they are all multiples of 5. We are supposed to do the same for the vertical axis. But looking at the values we have, the values are so close to each other. And when we do it like that, our graph will become so small. Meanwhile, you want to achieve getting a graph That is more than half of the graph working area. So we do something which is called breaking the axis. We tell them, we know we are supposed to start from 0 and move accordingly. But looking at the values we have, we want to start with maybe 2.5 or 2.6. A value so close to your first value. That is how you choose it. So somebody will choose 2.6, somebody will choose 2.5. You are all right. And with what I'm drawing right now, I would like to start with 2.6. So 2.6. Now, starting with 2.6, normally I'm supposed to go to 5.2, but I'm not going to do that. And I will tell them why I'm not going to do that. I'm going to seek permission to do what I want to do. And to seek permission, we bring this sign telling us that we've broken the axis. It looks like a Z. This sign is telling me that I'm not starting from 0. So from 2.6, I'm not necessarily supposed to move to 5.2. No. But whenever I move from 2.6 to, I'm supposed to keep that constant interval. So look at our values. We have 2.6. We want to get to 3.6. So if we are to move by 0.1 interval, 2.6, 2.7, 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. Our graph is now so large enough. And what are we doing? We just beg them. We know we are supposed to start from 0. We know we are supposed to start from 0. But looking at the nature of values we have, the values are so close to each other. We are going to get problems. So we want to start at any number we want. But we promise to keep a constant interval. So if my constant interval is 0.2, it will be 2.6, 2.8, 3.0, 3.2, 3.4, and so on. But with this graph of mine, I'm choosing to use an interval of 0.1. So from 2.6, I move on to 2.7, 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. If you begin with 2.5, that means your last value over here will be 3.5. This value wouldn't enter the graph. So if you begin with 2.5, for yours, your scale should be every big box being 0.2. So 0.2.5, 2.7, 2.9, then so on. You move. But I've chosen the easier way out. I just looked at my first value. You see, it is 2.641. So I kind of ignored the 41 and started with 2.6. Then on, I moved with a close interval of 0.1. So on my vertical axis, each big box represents 0.1. Only that I didn't start with 0. I started with 2.6. And what I've done is what is called breaking the axis. So in this case, if I'm asked to plot any point, each bigger box starting from 2.6 upward is equal to 0.1. So with my graph on the vertical axis, starting from 2.6, each bigger box is equal to 0.1. Which means we have 10 smaller boxes in each bigger box. So if one bigger box is equal to 0.1, then one smaller box will be equal to 0.01. It's as if you are divided the 0.1 by 10 smaller units. If in your graph, a bigger box is equal to 0.2, that means each smaller box is 0.02. If in your graph, each bigger box is equal to 0.5, that means each smaller box is equal to 0.05. If each bigger box for you is 1.0, that means each smaller box is 0.1. If each bigger box for you is 2.0, then each smaller box is 0.2. If each bigger box is 2.5, that means each smaller box is 0.25. And if each bigger box is 100, that means each smaller box is 10. So whatever your bigger box is equal to find what each smaller box represents, just divide that one by 10. And in mine, from 2.6, I move to 2.7. That means each bigger box is 0.1. From 2.7 plus 0.1, 2.8. 2.8, 0.1, 2.9, and so on. So each smaller box for my graph on the vertical axis represents 0.01. How do I plot these values? So quickly, on the horizontal axis I have 10. This is my 10. On the vertical axis I'm supposed to have 2.641. So this is 2.6. And from 2.6 to 2.7 there are 10 bigger, smaller boxes. Each smaller box is 0.1. So this is 2.6, 2.61, 2.62, 2.63, 2.64. Then we have 2.641. It is not exactly on the 2.64. It is slightly above it. Always consider each smaller box on your graph like this. Use your own intuition. Divide it into 3 in your mind's eye. So in my mind, I have 1, this way, 1, 2, 3 divisions. So each division below the first mark is less than 0.4. But if from the first mark to the next mark, the value is supposed to be from 2.4 to around 2.7. Then above the second mark to the last mark, over here, that part is 2.7, above 2.7 to around 2.99. Then the last part becomes your value on the graph. So I have 2.641. This is my 2.6. 2.61, 2.62, 2.63, 2.64. So 2.641 will be slightly above the 2.64 mark. That is my point. So it is not exactly 2.64. It is slightly above it. So we consider that one as 2.641. Now, in our second value, we have 15 on our horizontal axis, corresponding to 2.832. This is 2.8. 2.81, 2.82, 2.83, and it is 2.832. So slightly above it. Slightly above it. That is our value. Then the next one, 25.0, over here, corresponds to 3.226. So this is 3.0, 3.1, 3.2. So 3.2, and we are moving to 3.226. So 3.21, 3.22, then 3.26. This is 3.23. right? This is 3.23, and we are looking for 3.226. So 3.2, 3.21, 3.22, and 3.226 will be somewhere in between, in the middle of a box. That is our value. Then we continue. Next, we have 30.0 on the horizontal axis, corresponding to 3.426. Now, this is 3.2, 3.3, 3.4. So we have 3.41, 3.42, 3.426 will be between 3.42 and 3.43. Then, next, we have 40.0 on the horizontal axis, corresponding to 3.598. So this is 3.4, 3.5, 3.51, 3.52, 3.53, 3.54, 3.55, 3.56, 3.57, 3.58, 3.59. The 9.8 will be so close to the 3.6 mark, like this. These are our plotted points. What we are left with is to draw our line of best fit. If you get confused along the line, please revisit the video, and everything is going to become clearer to you. The line of best fit is supposed to pass through most points, with some of the points lying on the left and on the right of the straight line, and also closer to the straight line. So this is our line of best fit. This is my first point. It passes through my second point, my third point. Yeah, my second and my third point. You see the first point lies to the left, the fourth point to the left, so close to the line, and the fifth point towards the right. That is my line of best fit. So don't forget, to break the axis means that you don't want to start from 0. You want to start from any value you want. But after starting from any value you want, keep a constant interval. The constant interval should be a multiple or a submultiple of 1, 2, 2.5, or 5. And whatever interval you choose, if you divide that interval by 10, you will get what each smaller box represents. So you can gently read your values. You realize this question just told me to plot a graph with L on the horizontal axis and T squared on the vertical axis. Then I realized the values for T squared are so close to each other. So the only way out is to break the axis. But sometimes the question will tell you, plot a graph with L on the horizontal axis and T squared on the vertical axis, starting from the origin. Immediately the question says that you cannot, please, you cannot break the axis. But if the question does not say starting from the origin, that means that you can break the axis. And when you break the axis, your graph will look so huge and more accurate as compared to someone who wouldn't break the axis. In some cases, you realize that you have to break the axis for both the vertical and the horizontal axis. In this question that I chose right now, I just broke the axis for the vertical axis and not the horizontal axis, because the horizontal axis, the values were well spread out. But remember, when the values are so close to each other, breaking the axis makes your graph bigger and more accurate. Since you broke the axis, do not expect the graph, the line, to pass through the origin. No. Because this is not your origin. You begged them by this symbol that you know the origin is from 0. But looking at your values, you don't want to start from 0. So you didn't start from 0. So don't force your graph to move from the origin when you break the axis. Please. These are what you need to know when you want to break the axis. And this normally happens in physics practical. Because the values you get over there, you realize some of them are so close to each other that you cannot use the normal approach for drawing a graph to tackle it. In such cases, please break the axis. Start from any number you want according to your value on your table. Then keep a close interval, because when you start from any number you want, you don't have the audacity to just move at any interval you want. No. The interval you move should be constant. If it's 0.1 interval, 0.1 interval throughout. If it is 0.2, 0.2 throughout. If it is 5, 5 throughout. That is what you do. Some people break the axis, then 2.6, then 2.9, then 3.0. So the interval over here is 0.2, then over here is 0.1. No. Make sure the intervals are constant throughout after breaking the axis. And I've given you the cue. Look at the first value. Use it to pick your first value on your graph. It is 2.641. Ignore the 41 and start from 2.6. So 2.641 will definitely not be on that point. It will be a little bit above that point. If you want me to prepare a video concerning breaking the axis for both the horizontal and the vertical axis, how that one is done, please leave a comment in the comment section below. And I'll prepare a video on that. I'll come with values that are close to each other for both the horizontal and the vertical axis values. Then I'll break the axis for both and draw the graph for you to see. But if you need that, you first have to comment below. Thank you.